Welcome back, student. In the last video we have seen the definition of permutation and how to write permutation in array notation. Now we are going to find in this example all the elements of S3. All elements of S3. Now what is S3? S3 is the set of all permutations. S3, the set of all permutations on three symbols or three objects. The set of all permutations on 1, 2, 3. So let us consider one permutation. Let sigma be a permutation in S3. Sigma belong to S3. Then sigma belonging to S3 means what? Sigma is a permutation from this set 1, 2, 3 to this set only. So sigma will map the elements of the set 1, 2, 3 to 1, 2 or 3 only. So for sigma of 1, there are three choices. Sigma of 1 can be 1, or it can be 2, or it can be 3. Once we choose one of the choice, so once sigma of 1 is chosen, then for sigma of 2, there remains only two choices. Two choices, except the element which is chosen for sigma of 1, you can choose from the remaining two. And finally, for sigma of 3, there is only one choice. After choosing sigma of 2. And hence, the number of elements in S3, by considering all the possibilities of sigma 1, sigma 2, sigma of 3, we get the number of elements in S3, that is cardinality of S3, as 3 choices for sigma of 1 into 2 choices for sigma of 2 into 1 choice of sigma of 3, that is 3 factorial, which is 6. So we know now that there should be 6 elements in S3. Now let us find all these 6 elements. So the first element is obviously the identity permutation. Let me call the identity permutation by the symbol I. So 1 will go to 1, 2 will go to 2, and 3 will go to 3 under identity permutation I. Now let us see when we fix sigma of 1, what are the choices for sigma of 2 and sigma of 3. So in the first point, we have seen that when 1 goes to 1, for 2 you have two choices, either 2 goes to 2 or 2 goes to 3. So we have taken 2 goes to 2 for 1 going to 1. So now we will take 2 goes to 3. So when 2 will go to 3, obviously 3 is having only one choice, that 3 can go to 2, or 3 is mapped to 2. Therefore, this permutation will be 1 mapping to 1, 2 mapping to 3, and 3 mapping to 2. Now we have considered the case of 1 mapping to 1, all two cases. Now consider the case of 1 mapping to 2. Then what are the choices for 2? Now since 1 is mapping to 2, so 2 is having only two choice, either it can go to 1 or 3. So let us see when 2 goes to 1. So if 2 goes to 1, for 3 there remains only one choice, that 3 has to go to 3 only. So 3 will map to 3, and therefore the next permutation which we get is 1 mapping to 2, 2 mapping to 1, and 3 is fixed. Now again let us see the case of 1 mapping to 2 and another choice for 2. We have chosen that 2 maps to 1 in the previous case. So let us see when 2 maps to 3, then what happens. So if 2 goes to 3, then for sigma of 3 there remains only one choice, that sigma of 3 has to go to 1. And therefore this permutation will be now 1 mapping to 2, 2 mapping to 3, 3 mapping to 1. Okay, so we have exhausted all the cases of 1 mapping to 2. Now let us see the case of 1 mapping to 3. So we fix sigma of 1 as 3. Now for sigma of 2 there remains again two choices, either 2 maps to 2 or 2 maps to 1. So if 2 maps to 2, then obviously 3 has to go to 1, and therefore this permutation will be sigma of 4 will be 1 mapping to 3, 2 is fixed, 2 maps to 2, and 3 maps to 1. And finally, the other choice of sigma of 2 when 1 maps to 3 is 2 mapping to 1, and in this case 3 will map to 2, and therefore sigma 5 will be, the last permutation will be 1 mapping to 3, 2 mapping to 1, 3 mapping to 2. And therefore we have considered all the 6 permutations of S3, and therefore S3 contains these 6 permutation: identity, sigma 1, sigma 2, sigma 3, sigma 4, and sigma 5.